All right, how's everyone doing tonight? So we're going to be covering this lesson 4. This will actually probably be a pretty short review. There's not a ton of new material to go over. Um, yeah, that about sums it up. So let's just hop right on in. So all this stuff should be reviewed to you. I'm going to assume you probably, have had this table like drilled into a million different times, a million different ways. Sorry, it's a little formatted weird. I could find some of the symbols for the population parameter, but I couldn't find others, and so it just kind of made a wonky table. But if you don't have it, I'd recommend writing it down. It's very useful when you're doing some of the problems or anything else like that. Uh, but yeah, no, I mean that's about it. You probably like had this completely drilled into you just with all the homework, all the quizzes, stuff like that. So next up, all right. So sampling distribution. So a sampling distribution is a sample is okay. It's a distribution of sampling statistics with a mean approximately equal to the mean in the original distribution and a standard deviation known as the standard error. An important aspect of these is the standard error. So it's the standard deviation of the sampling distribution. Also, if you guys have any questions, just be sure to type in the chat. I will get to them. That's what I was forgetting. Sorry. It's been a long week. Yeah, sampling distribution. The impact of sampling size. So this is something that's very important, very key to pretty much like all of stat is the larger the sample size gets, the more normal distribution will occur and the standard error will decrease. So therefore, standard error and sample size have an inverse relationship. As one goes up, the other goes down. Just always remember that, it'll be key to helping you on quite a few of the problems. So yeah, that's that. All right, confidence intervals. It's bringing back a lot of stuff that you have seen before and adding in some new stuff. So what is it? Well, it's a range of computed values using sample statistics to estimate an unknown population parameter with a stated level of confidence. So the official equation for it is sample statistic plus or minus the margin of error. The margin of error is generally a multiplier times standard error. And so it depends on two factors. So the level of confidence, which determines the multiplier, which goes way back to the empirical rule. It's in all these questions, it's either going to ask you for 68%, 95%, or 99.7%. In which case, if it's 68%, then you're going to be multiplying it by 1. If it's 95%, you got to be multiplying it by 2. And if it's 99.7, you got to be multiplying it by 3. The most common is definitely 95%. So I just have that down, to a T because that's going to be the bulk of the problems. And if it's ever something that's not one of those values, they will definitely give you the level of confidence, the multiplier of which to do it with. And then, you also need the value of the standard error to compute it. So, if you guys don't remember the empirical rule, it's basically saying that, everything that's plus or minus one standard deviation from the mean is going to take up 68% of the total values. Everything that's 2 standard deviations plus or minus away from the mean is going to be 95%. And everything that is 99.7% is going to be 3 standard deviations. So it makes sense when you kind of look at it that way. All right. So when it comes to answering confidence interval questions, there's a few things that you just always have to keep in mind. So the final answer will always be a number, but it's got to be like some kind of interval. Just stuff to keep in mind. And you always have to write a conclusion statement when interpreting the data. So this is a sample conclusion statement. It's basically, I am, whatever confidence level they've given you, percent sure that the population, insert the population parameter or the statistic is between, insert the lower number, and then insert the higher number. So, just remember that for when you ever have to answer some of the questions. All right, so here's an example that I'm just going to work through, you guys. So it's asking you to form a 95% confidence interval given a representative sample of 673 PSU students if they enjoyed. Okay, so basically what's happening is they're asking 673 students if they enjoyed chemistry. The sample proportion is 0.44 and a standard error is 0.011. So then you're just going to whip out your handy dandy equation. So the confidence interval is equal to the sample statistic plus or minus the margin of error. So that's 0.44 plus or minus 2 times 0.011. So then your interval is going to be 0.418 to 0.462. So then when you interpret that, it's going to be I'm 95% confident that the population of students who enjoyed chemistry is between 0.418 and 0.462. And so any value that's in between that interval is a reasonable estimate for the true population value, because all of this is just trying to get at like what the true population actually is. All right. So another fun time is bootstrapping. I'm sure you guys have done a lot of this stuff, with StatKey and everything. That's going to be the primary way that you're going to use it. So basically what bootstrapping is a resampling procedure that uses data from one sample to generate a sampling distribution by repeatedly taking random samples from the known sample. It's also called like sampling with replacement. Basically like visualize it's kind of like bingo, where they have all of those ping pong balls or whatever that have the numbers written on them, and they take out a number. They, write it down. Let's say they got B4 or whatever. But then instead of just taking it out, they throw it right back into the pot, and that way you could potentially get B4 again. You're just like completely drawing off this group to try and inference what the total would be for an entire population just from this very small sample. So how do you construct a confidence interval? Well, you really have two ways to do that. So you could do the standard deviation method, which is, going back, just doing the whole confidence, sample statistic plus or minus 2 times the standard error, that stuff. Or you could do the percentile method if you have it, which is the preferred method. So, you're basically just going and using StatKey and, entering like the 95 in the middle and then just finding the other bits. And, it works regardless of the shape. It's, very nice, but, I'm not sure how your tests are going to be. I just don't think that's going to be okay. I'm not sure how the tests are going to be phrased, but I imagine it's probably going to be, if anything, a little bit more of either the confidence interval method of using the sample statistic plus or minus the standard error, or it's going to be, if they do give you a percentile method one, then it's just going to be like counting. They're not going to make it like that easy for you, or they'll ask you to pick the correct percentile method one. It's going to be like one of those 3 options for how this is going to appear on exam. All right. So as I told you guys, this is a pretty fast lesson. So we're already into the review. So I'll give you guys a little bit of time to work through this question, then we can go over it. All right, so I see you guys are kind of getting this one. Yeah, it's going to be A because it's going to be wider. A common pitfall is you might think, oh, you're increasing the sample size or something, so that's going to decrease the standard error. However, what you're actually doing is you're just increasing the confidence level. So you're adding more values into it. So yeah, it is going to be wider as an effect. So kind of a long question to read through. I'll just let you guys add it. All right, so I'm seeing a little bit of confusion here. So it's going back to the inverse relationship that I was talking about earlier. Since you're increasing sample size, standard area is decreasing. It's always going to have that relationship where, if you increase one, the other is going to decrease. So in this case, you're actually drastically increasing the sample size. So standard area is going to drastically, it's going to be much less than 5. But in this case, it's just, as long as you just recognize the relationship, you should be fine. If you have any questions about this, just let me know right now. If you want me to go over it again, I can go over it again. Just whatever you guys need. Just let me know in the chat. All right, so next up, I will read this one for you. It's just a nice little straightforward fill in the blank. This is similar to like a lot of questions I had on my exam where basically what they do is they give you like a pre-written statement and you just fill it in with the answers. Sometimes it would just be blank, or most of the time it was just they'd give you like one of two options. So just kind of just use the blank. So all right, so what it's asking for is using a sample of 4,079 inventory plots, scientists gave a 95% confidence interval of 9,600 to 13,600 tons for the mean amount of carbon per square kilometer in tropical forests. Interpret the meaning of this confidence interval. All right, so I'll give you guys a little bit of time to interpret. All right, yeah, you guys seem to have gotten it pretty well. So for this one, I put population. It really is regarding the tropical forest. The inventory plots was a way to kind of throw you guys off a little bit. But yeah, no, just plug and chug. It's really the 95% that they say up there, inserting population that they want, and then the low to the high value. So, there you go, guys. Next Next up. All right, this one's kind of easy. So, in the population of all citizens of Turkey, median age is 30.2 years. This value is a like one, is it a statistic or a parameter? And the age in years is what kind of variable? So, let you guys at it. All right. Yeah, looks like you guys got it. It is, in fact, a parameter, and the age is a quantitative variable. Next up, review 5. In a random sample of 525 Penn State students, the mean height was 67.009 inches, with a standard deviation of 4.462 inches. The standard error was computed to be 0.195. Construct a 95% confidence interval for the mean height of all Penn State students. All right. So I'll give you guys a little bit of time to interpret this. You guys don't have to do the end like, um, you know, I am 95% confident, all that stuff. I just want you guys to give me like the range. All right, so let's go over this. All right, so I hope I didn't get any math wrong. If I did, I'm sorry. This is the reason why I don't want to become an engineer. All right, so when you're computing a confidence interval, just gotta remember the equation: sample statistic plus or minus the margin of error. And that, you just gonna break that down into, since it's a 95% confidence interval, it's going to be a multiplier of 2 times the standard of error, which was 0.195. So then when you have to end up doing that, it's 67.009 plus or minus 2 times 0.195, or 67.009 plus or minus 0.39. And then, just subtract it to get the lower value, and add it to get the upper value. If you guys do a little bit of rounding, it's okay. I'm not gonna I don't care, but just be careful on the exams, because sometimes they get picky. All right, next up, I think this is the last one. Tried to make you guys at least think a little bit. All right, so which of the following sets of data could result from the bootstrap sample that is given below? So here it is, and I told you, all the information you gotta know. So have at thee. All right, so I think this one really got to you guys a little bit. So basically, the reason why it can't be A is because it has its sample is too large. It has 11 when there are only 10. And basically what you're trying to do with a bootstrap sample is you're just trying to recreate like the sample over and over and over and over and over again. However, you can't make it so that it exceeds the previous sample. It has to always be like the length that that other sample was. So that's why A can't be it. And trust me, they're going to throw in, curveballs like this all the time. They're going to make it where there's one that's too long, one that's too short, and they're probably going to do something else like I did, where all of a sudden you have this 4 in here. However, there's no 4 in the original sample. So therefore, it cannot be, an accurate bootstrap sample. And then C, I tried to throw you guys off a little bit by making it repeat a lot. However, you can have repeating numbers. There are chances where, you might have a bootstrap sample and nothing is repeated. There are chances where you're only going to have like 1 or 2 things repeated. But, there are, of course, times where everything might be repeated. It's just, luck of the draw, stuff like that. So, but yeah, because it is only, there's only like 10 numbers in there, and because they were all in the original bootstrap sample, it's the only one that actually qualifies. So with that, that's the end of the review. If you guys have any other questions, just let me know and I can go through. Sorry if this went a little fast or anything like that. I got like 2 hours of sleep. It's just been one of those weeks, So what can you do? Anyway, This session is going to be recorded and put on YouTube, and next session is going to be this Sunday, same time, same place. So yeah,